we present CausalChat, an interactive causal model development and refinement tool using large language models. In the following, I will walk you through the major components of CausalChat. There are 5 components in our interface: the control panel, the causal graph panel, the causal debate chart panel, the justification panel, and the causal relation environment chart panel, or latent factor panel. To start with, we click on the Choose File button to specify the dataset that we're interested in. Here I choose the opioid dataset. Opioid dataset contains predefined social economic attributes that are considered important in performing causal inference on opioid death rate. By setting up some parameters in the control panel, we can get an initial causal graph waiting to be refined. Let's have a look at possible edge configurations that can occur in the causal graph panel. In the causal graph panel, each node represents an attribute in the uploaded dataset, and each edge represents a relation between 2 attributes. A directed edge represents a causal relationship from source node to target node, whereas an undirected edge doesn't imply any directionality needs to be directed by the user. There are multiple kinds of edges that would appear in the panel. A positive edge, which is an edge in green, stands for a positive causal relation between source node A and target node B. That is, increasing the value of A would cause B's value to increase. Meanwhile, reducing the value of A leads to the decreased value of B. The counterpart of this scenario, the negative edge, signifies an adverse causal relationship. Therefore, we mark the negative edge red. A latent edge appears when connected nodes are latent attributes. Latent attributes are the attributes introduced within the framework that are not included in the original dataset. Now let's look at some basic use cases to modify a causal graph. With the icon buttons at the bottom of the panel, users are able to easily interact with the causal graph. Description of each button is shown with a tooltip. For example, here we demonstrate how to add a directed edge. To add or direct an edge, first click the Add or Direct Edge icon button. Then the causal panel will proceed into Add or Direct Edge mode. By clicking the desired source node and target node in sequence, a new directed edge will be created. The strength and sign of the edge will reflect the computed causal effect utilizing structural equation modeling. A primary feature of CausalChat is conducting edge auditing. In practice, a well-accepted causal graph can be constructed by exploiting the wisdom of crowds. CausalChat achieves another kind of causal wisdom of the crowds by applying causal knowledge learnt by ChatGPT. Here, we introduce the causal debate chart, where the user can audit edges beyond their knowledge base and modify the current causal graph accordingly. A causal debate chart evaluates all possible causal relations between a 2-variable pair. The way to interpret the chart is by looking at the comparative bar length at each side. The side with longer bars is more likely to be the cause, and hence the short bars correspond to the effect. Here in this case, the opioid dispensing rate is the cause of opioid death rate. When we treat both variables as numerical variables, cause and effect also entails trend information. Here in this case, higher opioid dispensing rate would lead to higher opioid death rate. This is represented by the red bar at second row on the left. However, ChatGPT gives a low rating to the right bar on the same row. This reveals that higher opioid death rate would not cause higher opioid dispensing rate. Other bars in the chart can be interpreted similarly. For instance, the left bar in the 4th row demonstrates the causal hypothesis that a lower opioid dispensing rate causes higher opioid death rate, though this relationship is considered not significant according to ChatGPT. A causal debate chart would be generated when a user selects a doubtful edge to audit. In order to overcome hallucination rating, users can verify the logic consistency of the corresponding justification. In CausalChat, when hovering on a bar in the causal debate chart, the user can read the justification for the corresponding causal hypothesis. In this case, the justification text explains why the causal hypothesis, food environment index causes violent crime rate, is rated 2, and there shouldn't be an edge between food environment index and violent crime rate. Sometimes 2 variables show correlation without direct causation. This is due to hidden confounders. Therefore, we introduce the causal relation environment chart in CausalChat, which can exhibit confounders and mediators suggested by ChatGPT. For the same reason, the user is encouraged to check and add potential confounders and mediators through reading the justifications. In the current example, socioeconomic status appears as a strong confounder for the Food Environment Index and violent crime rate. In addition, no mediator would mediate a causal effect between these two attributes. As a result, the user adds a confounder socioeconomic status and disconnects the link between Food Environment Index and violent crime rate. In another example, a user seeks an actionable mediator that can reduce the opioid dispensing rate while increasing the number of primary care physicians. Access to alternative treatments is an effective mediator as it offers diverse pain management options. With more doctors, patients receive holistic care that prioritizes non-opioid treatments like physical therapy, behavioral therapy, or non-opioid medications. This reduces reliance on opioids. More primary care physicians also means better patient education on opioid risks, making alternative treatments more viable, thereby directly contributing to a lower opioid dispensing rate. Repeating the previous refined steps, we can obtain a coarse causal graph. However, this causal graph might not be detailed enough or lack of variables that can be intervened on. CausalChat incorporates the Create Subnetwork feature, which allows users to focus on local causal graphs of interest. To achieve this, one needs to click the Create Subnetwork icon button and click Attributes of Interest. With selection being confirmed, a model tree will be plotted in the control panel to record changes made in each causal graph. One can switch between models by right-clicking to select the wanted model. In this scenario, the user observes this causal pathway from number of mentally unhealthy days to opioid dispensing rate and to opioid death rate. The user wants to explore possible interventions on this pathway that can help reduce the opioid death rate. So, the user asks to demonstrate all intervenable latent factors by clicking the Find Latent Factors icon button. In response, a latent factors chart is shown for each queried attribute. The chart would present intervenable variables that can either positively or negatively affect the selected attribute. By reading the justifications for the latent factors, the user chose to add latent factors, such as access to mental health services. This indicates that building more mental health institutions can be an action to further reduce opioid death rate. The other two latent factors, prescription drug monitoring programs and availability of alternative treatments, can negatively impact the opioid dispensing rate. Prescription drug monitoring programs can achieve this by enforcing stricter opioid prescription limits, while alternative treatments can reduce reliance on opioids, ultimately helping to lower the opioid death rate. For more details, please refer to the CausalChat paper.